Today we're going to walk through the entire process of creating your first trap, deploying your first operator, and then connecting that operator to your trap. We'll dive into what our new Create Drosera app command is, what it creates, and then walking through a simple example trap to understand the different commands and what you can do once your trap is created. We'll look at the installation process for running an operator locally, and then we'll run that operator against your trap. First, we will bring over our terminal and running the new Create Drosera app command. So npx at Drosera / create Drosera app. We'll be able to name this, so this will be the repo name and also in the node modules. So for this example, let's just do cool Drosera app. What this will do is in your current directory, it'll create a folder with the contracts and even a client so you can connect to the front end. So let's just open that and see what it looks like. So what you'll see is a client directory, a contracts directory, and some other boilerplate that we'll need to run our application. So in our contracts directory, we have a full Foundry suite with scripts, your source, and testing to test your trap out before usage. A README kind of explaining what you need with installing Foundry. We prefer to use Bun for dependency installation, so if you don't have Bun, we recommend that you install Bun. And then also installing other parts of our process. Also some of the private keys that you'll need for running the operator and also deploying your contracts. We have an example environment file that we'll go through. In this case, we're going to be running on the Ethereum Haleski blockchain. If you want to test out for testing purposes, you can use an Anvil private key. Your private key here will be for deploying your physical contracts. And note to this that you can do both deployment and also running your operator if you choose to on the same address. The operator private key, again, could be the same as your deployment private key if you choose so, or you can have a completely different private key for running your operator. The deployed Drosera address, so this is the entry point to the Drosera protocol. With this, you will point to whatever network that you want to deploy to. In this case will be Haleski, since we're currently only deployed on Haleski, and then the chain ID for that specific chain. In this case, Haleski is 17,000. On the client side is based mainly on the user. If they have some type of user interface that they want to interact with, if they want to create POCs using Drosera traps to show a visual, you have the ability to now have a Next.js project that you can create a front end if you choose to. If not, you do not have to. So what I'll do is bring up a example that I've already created to kind of walk through that process. One second. So this is the operator demo. We'll go through the Drosera TOML file in a second, but let's first walk through the response contract. So whatever response contract that you want the trap to respond to, we'll go here. Make this screen a little bit bigger. With this, the response contract for this is going to be very simple. All it's doing is on our side, we'll be setting a user, and the trap itself will be looking to see if a user is set. And if they are, it will trigger the global variable up here, the internal ready to start bool. Right now it's set to false. but the trap is going to, every block, see if a user is set, and if so, update that bool to say ready to start, and then it'll clear the user so that we can refresh this if we need to and try it again. At the very bottom, the interesting thing with the entire trap setup is we can actually have a trap config trigger, and only them trigger that response function. So if there's sensitive information that you would like to have protected through admin privileges, you can have your trap as an admin specifically to that function. So the set ready to start is now only callable by our trap config. So once we go through and deploy our trap config, this will be called and only called by our trap itself. So when it's triggered, this will call. And we'll go through the trap contract itself. So trap contracts inherit a iTrap interface, which is just two functions, a collect view function. This function is mainly used for collecting data on chain. So in this case, we're going to be looking to see if there was a user added. We'll get that user. If the user is set to 0, we'll return a false. So it either, in this case, returns true or false. If there is 0 address, then we will return false. This collect is then put through the should respond in the operator side. Should respond is just a pure function, so you cannot get any chain state from here. You'll pass the chain state from the collect function only. So the should respond is really doing something with that data that it's collected. The nice thing about this is the bytes array is a time series of X amount of blocks. So you set the amount of blocks in your trap config or in Drosera itself. So these are some of the standard keys that you'll be using. We'll go through this quickly. The path is the path to the bytecode that you've compiled. So in our case, it's in the contract/out file, trap.json. So it'll grab this bytecode. The response contract is the deployed contract that we want to respond to. So I've already deployed that on Haleski. It's right here, so we'll add that here. The response function is the function on that contract that we want to respond to. So this is basically a function signature, and we have to match this function signature, this input, to the trap should respond output. So in this case, we're saying that we should respond. So it's true. That means it's going to fire off. And this encoded data here is whatever your response contract is taking in. And so we can see here that the set ready to start is taking in a bool parameter. So this needs to match what you're setting here and also what you're returning from your should respond. So this encoded data needs to match those parameters. If you don't have any parameters, you don't have to set anything here. So this is really only, you can have it as just empty. And what this will do is just basically say it should respond to a function that doesn't take any parameters. But if you do take parameters, just know that you have to encode those parameters in the same fashion that they are produced in the function. So in this case, we're going to encode bytes as true. With that done, we will have to also hard code that response contract in here into the trap config. So you'll need to, if it's not deployed yet, you'll need to deploy that contract and then get that address and then hard code it here. When being simulated off chain, the constructor is not used. So you cannot put any arguments within the constructor, but you could do things within the constructor. So if you need to set anything, you can do that. But the constructor really isn't used. The collect output here is what is being returned from the collect function. This struct could be called anything you want. It could have anything that you want as far as fields. It really doesn't matter as long as it's returning the encoded struct from the collect and then passing it to the should respond. So you're seeing that it's returning just a single bytes, where here it's returning a bytes array or array of bytes. And because of this is all of those blocks that you're saying that you want a sample size of. So in our case, we want a sample size of 10. And why this is nice is with that sample size, you can do time series analysis on that data that's passed in for the last 10 blocks if you're looking for something very specific. But if not, you can just use the first entry in that array to grab the latest data. So data 0 will be the latest, where I minus length would be the last in that block range. So you just keep in mind that 0 here is going to always be the latest data that was passed from the collect function. And then in here, we're just double checking that was it false, that whatever was passed back here, if it was false, we're going to return false. This is going to do nothing. This will trigger nothing. But say that it was caught in the collect, we're seeing that it was returned as true. We are going to then return true, and then the encoded data that we want to pass in, and then this will fire off that method. From that, I think we have everything where we can start diving into the actual operator itself, running the operator, and then also going into your Drosera toml and configuring what you need to do to create your first trap. So from there, let's bring in the installation instructions for the actual trap operator binary. So if you would like to run your own operator, you can. You don't have to. You can use the protocol whitelisted operators, who will then pick up your trap to run that. But say you want to do this privately and you want to test your own thing, you can run your own operator locally. With that, the best thing to do is, depending on your operating system, you can go to our release page. In that release page, you can see our latest release at time is 1.13, and go down here to see which operating system that you have. We are also using the Drosera CLI to do a lot of these commands, such as opting into your traps, opting out of your traps, and then also registering your operator once you have it. At time of creation, we only have the one Drosera operator, which is running on x86, and so I'll go through what you can do to get around this, but we will have some Apple Darwin TARs as well coming in the future. But for now, there's only x86. To get around that, though, you can go and use the Docker image. So you can run this Docker image locally as well. In the Docker image, you'll just pull the latest and then run the commands from Docker itself. I'll also show you the list of commands, which are also included in the run create Drosera app. So you'll have all of these commands ready if you're running the operator binary, or if you're using Docker. The make file in here will have a list of commands that you can use when running that operator. So the Drosera operator, to register, you'll need to register your operator within the network if you haven't already. If you have, you don't need to do this every time. But if you are creating an operator for the first time, you'll need to register that operator within the network so you can actually opt in and opt out of traps. The run operator command is also here, so all of the flags that you'll need to run that operator. The environment variables are in here. I would suggest using some type of environment file, but you'll be able to add those in the environment file and grab them straight from here. Opting in and then also opting out of traps. So once you have deployed your trap to the network, you'll want to opt in if you're running your own operator. So after you've registered it, now you can opt in and opt out of any trap that is either public or also private that the trap creator has whitelisted you. So you can whitelist yourself if you're running a completely private trap and just run it yourself, or if you have a friend that's also running an operator, you can whitelist them so they can opt in to your trap as well. So with the opt-in, you'll add the trap config address. So we'll walk through there, what it looks like, where to grab it. So when you want to opt in, all you have to do is apply that address right here. So the next step that we can do now is, now that we have everything set up, we've pointed our path to the compiled contracts. We've deployed our contract, our response contract. So this is the address. We know the function that we want to set for the response. Cooldown period blocks. So what this is basically a way that we have a buffer period that it's not firing off again. We have, in this case, 30 blocks. So it will not look to try to run for another 30 blocks. And after that, it'll start back up again. The min number of operators is what is the minimum amount to start running. In this case, we have 1. And what is the max amount of operators that we want? That will be, in our case, 2. So we don't want any more than 2 operators running at a time, but that could scale up to 10, 20, 50, whatever the max that you feel that you would like. You can add that there. Again, we talked about block sample size. That is what what is being put into the should respond. So in our case, we have 10, and so it will collect the last 10 blocks, and every block added, it will just pop the last 10th block off, and so you'll have a constant array of 10 blocks if you choose to analyze to do whatever you want to do with that. In our case, we want to make a private trap, so the private trap can be true or false. Private traps allow us to create a trap that whitelisted operators can join, and protocol whitelisted operators cannot. So this allows you to whitelist specific operators that you want to be able to opt into your traps. And then the whitelisting is really just an array of addresses that you choose as operators that you want to have the ability to opt in. This doesn't force them to opt in. This will just allow them to opt in if they choose to. So in our case, we just have 1. That'll be us that we want to opt in with. So from there, we are going to run our creation of our trap. So we have the Drosera CLI. So you'll need the Drosera CLI installed. And once you do, we'll be able to have a couple different methods. So Drosera help will show a couple different methods that we have the availability to. So we have our config, our plan, our dry run, and apply. And what these will be used to is you can plan what you want to do and just to see if it will work, see what's changing. Every time we run this, it'll check this Drosera toml to make sure if there are any changes within this. So say we deploy our trap and we accidentally put the wrong response address. Once we update that, we can go in here and do another apply or a plan or a dry run. Dry run is to see if everything's good to go before it actually executes the transaction. But the apply is what actually does the application to the blockchain. So this will apply the state changes once you've done your contract. So in our case, let's do a Drosera apply. the cooldown period below block limit. So let's move that up to, let's say 40. We do have some current protocol limits. Okay, so now that we've seen create trap config, we've called it my trap. So every time you want to, you can have more than one trap if you want to in this. So you'll just label it traps in my trap, but you can label it something else if you choose to. We could see the bytecode is pushing to there. What I'm going to do is there is a gotcha here. So before we do that, we're going to, now that we've added all of our hard-coded things to this, you'll just have to remember to compile your contracts no matter what you do with this trap. So say you've created it and you then went back and deployed your contract, your response contract, and you're like, okay, I have my response contract, I'm going to put it in here, but you forget to compile again. That's a gotcha. So you'll have to compile again after you add this because it is updated. So with that said, we'll cd into our contracts and forge build, which will go and build everything just so we know that we are good to go. Go back out and we'll do a Drosera apply again. So it's collecting the blocks just to make sure everything's good to go. Again, we can see what the trap code, bytecode hash is. We can see the response contract matches what we have here. Same thing with the response function. We can see the seed node DNR, cooldown blocks, all of that information. Currently, it doesn't take any Dro token to actually deploy anything, so it's free. So we'll see that, and then we'll see the estimated gas to run the trap config deployment. So we'll say, of course we want to run. It's going to execute. And after that's done, you can go to your Trap Explorer and see what it's done. It's created it. This is our new address, so you'll see the address down here has been created for you and added. So this is now your official trap config contract. With that said as well, say you want to update something. You want to have max number of operators to be 3 now. You're going to go back in here. You're going to do another Drosera apply. And what we're going to do, we're not going to be able to do that because we have certain things set. So let's say we want to do set to a 41 block cooldown. And we can't do this either. We might have to update this. Let's see if that works. So what we're getting right now is because we're applying too quickly, the apply config failed, so we're going to have to wait after a couple blocks, because if you didn't do this, you could change something on the fly. If, say, the cooldown period hasn't finished yet, this could cause issues going forward if you change something when something hasn't been done yet. So we will have to wait for about 40 blocks. We'll come back to this in a second once that's done. Okay, now that we've waited for that, let's try this one more time. We'll go in here and do a Drosera plan just to see if we're good to go. And you can see that we've slightly altered the response function from set ready to start with 0 param and we'll see that that's changed. We don't want to do that, so let's add that back in. Let's run that again to see if anything's changed. And nothing to apply. So we are good to go. We know that everything's ready, everything's set with the whitelisting. This is going to be our address of the operator that we're going to create next. We now know that the address for our trap config is here, so we can use that. And we've double checked that our response contract is the one that we've deployed. So now we can move on to the operator side of things. Like I showed you before, we can go in here. So it's depending on your system of what you're running. So in the case that you are running on an x86 machine, you'll be able to come over to the releases page and download the binary directly. So you'll come here. This is the Drosera operator. This is what you'll take to get the actual binary to use to run. And then if you aren't on an x86 machine, you could still use Docker, which I will show you guys how to use Docker today with it. And again, all you have to do, I already have this currently, is just pulling the latest Docker image. And then what we'll do is, instead of just running straight from the binary, we're going to run it within our Docker environment. So the same thing really applies. In this case, we'll test it out with the help function just so you have an idea of what it's going to look like. But it really should be just like you would run in your basic terminal. You'll see the different commands that we'll have. So node starts the operator itself. Register will register that operator, which we will run this command first to see if this one's already registered or not, opting in and then opting out. So all of these commands are already in the makefile that is provided, so you'll have this ahead of time. But just need to understand that if you do use Docker, you'll just have to concatenate that on the makefile. Instead of running it like a binary, you're going to be running it straight from Docker. So let's try to first register the operator. So we're going to come down here to hide some of the private keys. We will just blur this quickly. But we'll do a make register operator. And 1 second. So we just needed to add the chain ID into your environment variables. I did not have that in there yet. So let's again do a make register operator. It will run. It's going to register the BLS public key into the registry of the protocol. And once that's done, all right. So we now have the operator registered. So we can clear that and unblur. So now that we have it registered, we can opt into the trap that we've deployed earlier. So we'll go back to our trap, our Drosera toml. We'll grab that address of the deployed trap. We'll come back to our makefile, and we will add that here. So now we're going to run the opt-in. We've already been whitelisted, so the address that we're running from the private key has already been whitelisted here. So what we're going to do is go back to the makefile, going to have to blur this again so we can run it. Do a make opt-in. And we will have to update the Docker instead of the binary. So one more time. All right, so it is running. It's trying to opt in to that contract or the trap config. So we get a success. So let's clear that. So now that we are in there, we've been opted in, we've been registered. We only have to register once. We can opt into any public trap now or any private trap that we are whitelisted in. So the last thing to do really is we're going to try to run our operator and see what the logs say. So let's change that. We have everything else set up. All of this is already good to go. So quickly blur at the very beginning so I don't show public keys and private keys more so. So we'll do a make run operator. Great. So now that we can see this, it is now syncing all of the blocks. We're seeing that we have should respond as being false. You'll see these messages that it's insufficient peers. So when you run your operator, you're basically connecting to the P2P network. Because there are no other operators in your selected config, you will not be able to gossip any messages back and forth, so there will be insufficient peers. But you will see that there's been an aggregated attestation for the actual trap, and you will also see the execution result, and if it's true or false as far as if it should respond or not. So we're seeing that should respond as false, which is true, because if you go back into our trap, we are currently looking to see if there's a user in the response, and we set that to 0. It defaults to 0, so there should be no user there. This user should be address 0, and so we're checking that in the trap, we're collecting that and passing it down, and it's seeing that it's 0, and so should respond should always be false until we update that on our end. So this will continue to run. You'll still see that it's returning false. So every block, this should update. It's listening to new blocks and then running your trap on every single block. You'll see if you're running multiple traps, you'll see different addresses here for execution results for the trap address. In this case, this is our trap address. So what we're going to do is let that run in the background. Next, we're going to run a call on the response contract to set the user. And once we set that user to something else, that should trigger our trap, and then we'll be able to see that result in here. Okay, so now that we have a script to set the user, I'm going to run the set user script, which will apply a user to the response contract here. So set user will have ready to start as false. The user will be then put into the global user. And so there will be a user, which the trap itself will check for. And if there is a user, then it will return true, which will fire off to the set ready to start. It will then set the user back to 0 and then ready to start to true. So let's do our make set user, going to blur the box, going to run make set user, and then as soon as I do this, we're going to switch over to our operator terminal, and we're going to watch the logs. All right, so that's firing off. We're going to now watch our operator to see the incoming. So now we see that it's pending transaction because it is respond true because that's been updated. It's creating the pending transaction and it's going to fire off that transaction. Here we go. We can see the transaction object being fired off from the operator itself, finding that action. You can read some of these logs here, but to kind of boil it down, there's a specific topic that says that this is true, that it was fired off correctly. And we can go back to should respond now being false because the response contract fired off that set ready to start, which now turns that address back to 0. So if we do a simple cast call to see what that address is, just to double check, we can see that it is now back to 0. So what we've done here is we've used our new Drosera, Create Drosera app to kind of create a scaffolding for a boilerplate for contracts and a client if you choose to use so. We've walked through a very simple use case for a trap that has a response contract. We've walked through how the Drosera TOML works, what are some of these fields and what do they mean. We've run our own private trap. So we've currently set it to true. We've whitelisted our own operator. We've looked at how we can install an operator locally and then run that operator. And then we've updated our response contract to trigger the needed function. So this should be everything that you need to get started. Feel free to reach out to us if you have any questions, and happy trapping.